One of the machines which was designed and built in PLC lab, University of Bridgeport, is the machine which is running on the platform of Allen Bradley PLC Slick 500. This machine was designed for purposes that in real world engineers have to implement it different manufacturers in one machine. So in this machine we have different manufacturers who design the machine, the part for the machine. This is Mitsubishi variable frequency drive, Cutler hammer, human machine interface, Allen Bradley PLC. This machine has a lot of recipes where students can learn behavior of the motor in different stages and for different application in the real world.
What we have here is a completely integrated system which has three distinct components: the variable frequency drive, which is the VFD, the human machine interface, which is the HMI, and we have a controller, the PLC, the Programmable Logic Controller, which is completely integrated into a system that controls the motor that we have on this side. So our options here are to do a hardwired control, which basically means I can control the motor from the switches that you see on the front panel, or I can choose to control it from the HMI. The HMI gives you a more visual control since it has a visual representation of what's happening with the motor, its current speed, its current status. Going into the panel, you see a lot of components. So this, of course, is the PLC, which is the heart and brains of the operation. And then you have other controls. This is a power supply. Now the power comes in, and this is a power supply, and you have a circuit breaker just in case there is a spike. And then you have all relays which will do the control action, and you have an Ethernet switch which allows the system to be part of a network, and you have an Ethernet module which will allow the PLC to go online on the Ethernet network. And we program the system to have multiple recipes. So if you take a look at the screen here, you have about 7 recipes. I'm going to run one recipe and show you how the system responds. I'm going to select the recipe, and I have to choose whether I want to run the motor in the forward or the reverse. As soon as you select a preset speed that you want the motor to run at, this panel will send a signal to the PLC that's inside, and there's a program running in the PLC which looks at the status of the signal and decides to send a power signal to the VFD, which in turn controls the motor. The reason for all these steps is isolation and better control of all the components. And as soon as I select forward, the motor starts running in forward. And now I have an option to select 3 preset speeds: low, medium, and high. So the application we just saw was a motor control application, and it's used in pretty much any place where motors are being used. For example, construction, steel, cement, food processing, any industry that uses motors and wants the motors to be controlled, they use pretty much the same setup.